Hi, everyone, and welcome back to another session of Big Data Days 2022. My name is Jeremy, and I'll be the host for this session. It's a pleasure for me to welcome our next speaker, Dr. Obay. As a PhD in artificial intelligence holder, a passionate trainer, and digital marketer, his expertise in big data science, machine learning, deep learning, and immersive technology are well demonstrated in more than 13 years of experience in various information technology industries. He has conducted numerous training courses for various companies, and he's also a trainer of a professional course about data science and analytics organized by Brickfields Asia College, Kuala Lumpur, Malaysia. He was also appointed to supervise PhD candidates by the International Islamic University Malaysia, Kuliah of Information and Communication Technology. Through this quick presentation, Dr. Obay will dive into the meanings of big data, data science, data scientists, projects and applications of data science, definition and significant differences among artificial intelligence, machine learning, and deep learning. Then we'll end by the involvement of big data in the Industry Revolution 4.0. Dr. Obay, whenever you're ready, the floor is yours.
All right, thank you so much. Hello and good afternoon to everyone. I'm so glad to be here. Thanks for having me. So I'm going to share the slides. Okay, all right. So just a quick one. We are going to talk about machine learning and artificial intelligence today. This is my email, this is my contact number, and you can find me on LinkedIn and Facebook for any further questions or discussions or anything you want to share with me. All right. Today we are going to go through the like a quick or understanding the concept of artificial intelligence, machine learning, and deep learning, and what are the differences among them. Then we will link it to big data, data science, and the tools and the requirements for those people working in the data science, the methodology that they follow when they work as data scientists. And then we will see like how data scientists they are going to use machine learning and deep learning and the types of machine learning and deep learning. Then we will look through the current applications or the most important applications of the AI, and we will look at also like some of the applications that we use it in our daily life. Then we will see what is the impact of machine learning and deep learning when it comes to the IR 4.0, which is the current one, and moving forward to the IR 5.0. All right. So to start with the artificial intelligence, machine learning, and deep learning, we just need to understand what are the differences among them or what is like each part about. When we talk about artificial intelligence, the main idea and the concept behind artificial intelligence, it's about how to make the computer smart or how to make the computer machine think and answer questions like how we think and answer questions. And how to do so, normally we instruct the computer machine. How to instruct the computer machine to answer questions like we answer the questions is by coding the computer machine. How to code the computer machine is by using the computer programming languages. All right. Then moving to machine learning considered as a field of artificial intelligence. So I would say like artificial intelligence is the umbrella of all. And then machine learning is considered as a part of artificial intelligence when we are going to learn from data instead of using fully coding instructions, because now we have a huge amount of data. So we are going to use the statistical algorithms, and those statistical algorithms going to learn from the available data that we have. Then we'll work on the new coming data. So we will apply all the learning on the new coming data. All right. Then moving from machine learning to deep learning is considered as a subfield of machine learning. Why considered as a subfield of machine learning? Because deep learning, it is all about artificial neural network, and artificial neural network is considered as one of the machine learning algorithms, and that algorithm become more complex to handle the huge amount of data that we have currently. All right. So in simple and in this it's like a kind of awareness talking about artificial intelligence, machine learning, and deep learning. So artificial intelligence is the umbrella of all, and machine learning is considered as a field of artificial intelligence. Then deep learning is considered as a subfield of machine learning. And currently, we are using all of these algorithms. We are using all of these technologies to work on data. And why to work on data? To work on data to make like a predictive model. The predictive model is going to make decisions or to predict things from the data that we have. Or we build a descriptive model. So we are going to gather the data into groups or subgroups based on the content of the data. Or we can have a recommender system. Recommender system is going to recommend things that we might like or things that we might like but we are not aware of. So it means all of those technologies, all of those algorithms, they work on the big data. So from our side as data scientists or as people, we are working in the field of artificial intelligence and machine learning. So how we understand the big data? When you read books about big data, even when you search about those vlogs and the blogs talking about big data, I don't think there's a definite definition about the big data. Big data is about the data that has the facts, and those facts we call them the V's of the big data. So the V's of the big data could be 5 V's, could be 6 V's, could be 4 V's, could be even 10 V's. It depends on the author of the book and depends on those people into this field. All right. But let's look at one of them, which is the 5 V's, which are the velocity, volume, variety, veracity, and value. When you talk about the velocity, it is about the speed of the data accumulated. So it's like how fast the data accumulates. Volume, it is about the scale of the accumulated data. Variety, it is about the structured and unstructured data and the formats of the data. And when we talk about the structured and unstructured, the the unstructured data is considered as 80% of the current data that we have. All right. The structured data is the data that comes into rows and columns. The unstructured data, the data that comes with the different formats, comes with the different like purposes. And most of the current data we have it currently not structured. So we need to structure the data into rows and columns, then we can work on it. Then the veracity, it is about the quality of the data. The quality of the data, it means like how good is the data to be used into analysis or into machine learning or into deep learning to get some insights from the data. Okay, so that's why there's a difference between the big data and good data. And I think in the future, from now in the future, we are going to hear more about the good data, because good data is the data that we're going to help us to get insights. And normally good data is considered as like definitely is considered as a small part of the big data or considered as a part of the big data. Okay, and the last is the value. When you talk about value, it is how to get the value from the data that we have. The value could be a profit, could be money, and could be like some improvement in the infrastructure of the country, some improvement in the education system, or something related to the healthcare, something related to the e-commerce, and so on. There are so many applications now, big data involved and artificial intelligence also involved to improve those sectors. All right. So this is our understanding about big data. And if you ask me personally, and with the respect to all, I can see the wonderful speakers talking about big data. It's like from my side, I would consider big data as the data that I cannot handle it by the Excel sheet. Okay, now the data, most of the data that we have now, we cannot handle it by the Excel sheet. Or the data that we have that we cannot handle the task that we are looking for by the Excel sheet. So what do we need to do? We need to move from the Excel sheet to use machine learning algorithms and deep learning algorithms. So when we have to move from Excel sheet to those algorithms, so it means the data that we have is considered as a big data. Okay, all right. So talking about big data, so people are working in this field, working on the data, or the field of studying and working on this data. We call it the data science. All right. Data science also is like quite difficult to find a definite definition about the data science, but data science is considered as any other science, which is the science of data, the science of studying the data, or we can say also it is the science of processing the data to get insights from the data, to uncover those insights, to make some recommendations, and to find new findings. And all of these things, we find them from the big data and the field of data science. Why? Either to solve a problem that we have with the data, or to make recommendation, or to have the new findings. Okay, so this is in simple is the data science. So people or those like working in the field and the data of the data science, we call them data scientists. Again, talking about data scientists, you might find like a little bit difficult to understand or to like to have a definite definition about data scientists. But in simple, I would say data scientist is someone who can extract insights from a messy data. First of all, why we call it messy data? Because most of the data that we have currently is considered as unstructured data. As I mentioned just now, 80% of the data that we have is considered as unstructured data. Unstructured data, it means a messy data. So those who are interested or curious enough to get those insights from the messy data, we call them data scientists. Some of the other definitions about data scientists can be like data scientists, those people who are really good in coding, who are really good in machine learning, who are expert in deep learning, or expert in in math or statistics. Definitely, data scientists, they need to have all of those skills, but you don't have to be that professional or expert in those skills. Why? Because you can always learn and you can always improve the skills of being a data scientist. All right. So normally, what data scientists then do? Data science, again, data scientists, those people who are working in the field of data science, and data science is the field of working on the big data. Okay, in simple and in general, data scientists, they work on three kind of model. They are going to build either a predictive model, so to predict things, and they are going to use all the supervised machine learning or all the classification and regression algorithms, either from the machine learning and deep learning. Or they build a descriptive model. Building a descriptive model, it means you are going to gather the data into a group or subgroups based on the content of the data, okay, to have a better understanding about the data. And then the third model that data scientists normally they build is the recommender system. So recommender system, it is about improving the sales for the e-commerce site, improving the sales for the company, either if they have a project or they have maybe some services. And recommender system will be a combination of the descriptive model and predictive model, and at the same time some analysis and analytics. Okay, so these are in general the model that normally data scientists work on. So what are the requirements and the tools that normally data scientists use, or what are the requirements or the tools that data scientists they need to learn, they need to practice, they need to improve those skills, then they can be data scientists and they can work on the data. Definitely, first of all, it is the artificial intelligence, machine learning, and deep learning. So they need to have good skills, they need to understand the algorithms that are available currently, then they need to improve the way of using those algorithms on the data. And as long as they are using those algorithms, then definitely they need to have the skills of the computer programming language. When we talk about computer programming language and the field of data science, for data scientists, definitely we have to talk about Python programming language and R programming language. All right. If you ask me personally, I will consider Python, especially for those people who are very fresh to the field of data science, big data, being a data scientist. I believe Python is going to be much easier for them to understand the computer programming language and much easier for them to start practicing and start improving the skill of learning the computer programming language. Okay. Then they need to have also some skills of data wrangling and exploratory data analysis, the EDA. Data wrangling or data cleaning, or sometimes even we call it data manipulation. It is about how to prepare the data that you are working on to be easy to analyze. So we are going to solve the issues of the data set. The issues could be missing values, could be some categorical columns to numerical columns, could be the data types, could be many other things that comes as an issue with the data set. We need to solve it, and normally we solve it during the data wrangling. Exploratory data analysis, it is about it's like the first step to find insights from the data set. And those insights, first of all, we are going to find the correlation or the relationship between the columns or among the columns. So we will see which one is correlated and which one can be used to build those predictive models. Then we need to have they need to have also the skills of the data visualization. So to visualize the data, to visualize the relationship between the data, to visualize the insights, to visualize the result, and to make it easy for everyone to understand what data scientists are doing, or how data scientists found the problem and how did they solve that problem. Then after that is the SQL. SQL, it is the way to communicate with the databases on the cloud. So definitely data scientists, they need to have some skills of the SQL. Then the last part, from my side, I would suggest also data scientists or those people in the field of big data, data science, being data scientists, they need to have a good LinkedIn profile, and they need to have a good GitHub profile. LinkedIn is considered as like the way then they can market themselves, they can reach people, and they can allow also people to reach them, to work together, to provide services, to find job, and so on. LinkedIn is considered as the professional platform for all those professional people, and I believe LinkedIn, it is like the best place to find the people into big data, data science, and working as data scientists. GitHub is considered as like a portfolio. So for data scientists, then they can they can have upload their projects. They can show their experience. They can show like what they are doing currently. They can also ask people to collaborate with them. They can also show people what did they do so far, and there are a lot of way to communicate and collaborate with others. Okay, so before I move forward about the requirements and tools, I always like receive these questions, and I believe like today the the wonderful audience also they might ask is like, do I have to be really good in math to be data scientist, or to be able to work on data, big data? Do I have to be really good with the statistic to work on the big data and big data scientist? Do I have to be really good in coding and so on? Or sometimes it's like I heard this comment is like, I'm not really good in math. I don't like math. I don't like statistics. I don't like code. So I might not be able to work on big data, or I might not be able to work as data scientist. So the good news is, now you don't have to be really good in math to be data scientist. You don't have to be really good in statistics to be data scientist. You don't have really also to be good in coding to be data scientist. It's good if you are good in math or good in statistics or good in coding. Why? Because you can speed up the process to be data scientist. But even if you are not, then you can learn all the third party tools, libraries, functions that are available currently to handle the big data. And you can see at the bottom, I have all of those current libraries, coding platforms, functions, and a lot of tools currently available. So you just need to invest your time in learning them. So you don't have to go and study. You don't have to like to spend that long time to to uh, to be data scientist. You just need like to start step by step, learning the coding, learning the tools, and then work on data set from one data set to another data set. I believe with those people who are really interested to be data scientists working on the big data in any field or the field that you are in, then I would say 3 months to 9 months, maybe 1 year. If you really work, if you really like the field, then you will be very successful data scientist working in your field. And one more thing, we need those data scientists. They not only they work on like one type of data. Now all industries, all fields generating data, so we need data scientists in each field. We need data scientists in engineering, and when it comes in engineering, we have civil engineering, mechanical engineering, electrical engineering. So we need data scientists in each field. When it comes to business, we need data scientists in business and with the different type of business. And like every office, every industry now, they are generating data. So we need people who can handle this data, this big data. So they need to be data scientists in their field. And it was said it is the best to be data scientist in your field. All right. So as long as we are talking about all of those tools and what data scientists they need, and what the skills of data scientists they need to improve. So moving forward, what is the methodology for data science, or what are the steps that normally data scientists follow to work on one project? So I would suggest to share these 10 stages. So those 10 stages, we start from business understanding. Business understanding, it is about finding the problem, and finding the main objective and the main aim. All right. After that is the analytic approach. Analytic approach, it is about finding, okay, which machine learning algorithm or which deep learning algorithm to handle that problem that it was mentioned in the first stage, which is the business understanding. Then after that, the data requirement, it is about, okay, finding what are the required data to solve that problem. Then data collection, it is about collecting the data and to check whether the required data available or not. And then one good thing about data requirements and data collection, most of the current problems, most of the current fields and industries, they have the data. So you are not going to spend that much of time in data requirements and data collection. You just need to work on whatever available data there. Then you can start solving the problem. Okay, moving forward is the data understanding. Data understanding, where data scientists normally, it is like the first step to start using Python programming language, start looking at the data, start looking at the columns and rows of the data, start to get some understanding about the data set. And during the data understanding, normally we figure out what are the issues of the data set, like missing value, duplication, categorical values, and many other issues. Normally we list them during the data understanding. And what do we use currently? We use pandas, one of the library, one of the tool that normally data scientists use to look at the data. Moving forward is the data preparation. Data preparation, it is about the data wrangling, as we mentioned just now, and it is about the exploratory data analysis. Data wrangling, it is about solving the issues that have been mentioned during the data understanding. And then exploratory data analysis is about finding the insights between or among the columns of the features of the data set. Then moving forward, it is about the modeling, and modeling is going to be using the machine learning algorithms. So it's like the implementation of the machine learning algorithm to build the model. So the data is already coming from the data preparation. So now we are going to use the algorithm to apply on the data set, then to start getting insights from the data set. If like it's like whatever is the model, predictive model, descriptive model, then definitely after the modeling, we are going to get a result. And those results, they have to be evaluated. So that's why after modeling is the evaluation. If everything is done, everything is okay, then we can deploy the model. Deploying the model, it means we are going to use that model to work on the new coming data. Once we use that model to work on the new coming data, then we start to collect feedbacks. Feedbacks can be positive feedback, so we can improve the model even more. We can improve the accuracy of the model, or the feedback could be like something, there's an issue with that model, then we need to solve those issues. So that's why these steps considered as iterative, and that's why also the data scientist job will never end. Once they build the model, they deploy the model, so it is like the first step when their job going to start. So because they need to work on the feedback and they need to improve the model, or they need to solve the issue of the new coming data. All right. So we talk about modeling, we talk about the machine learning, building a model, evaluating the model, and just to emphasize on the machine learning and artificial intelligence and even deep learning. So we are going to like slightly into the technical part, talking about the types of the machine learning. Currently, we have four types. I believe we have four main types of the machine learning: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. When we talk about supervised machine learning, we say train me. Why train me? Because we use supervised machine learning algorithms to work on the data that we know what is the data about. So the data is labeled. The description of the data is there. All the data are predefined. So what do we need to do? We need to use the algorithms, those statistical algorithms that belong to supervised machine learning, to learn from the labeled data, to learn from the predefined data. Okay, and that learning will be applied on the new coming data. And the new coming data is the unlabeled data, not the predefined data. So all the labeled and the predefined will be automatically labeled and predefined to the new coming data. Okay, and some of the applications for the supervised machine learning is the regression and the classification. Regression, we use those algorithms to predict the house price, to predict the tax fare. And then for classification, I think you are familiar with the sentiment analysis, and we use it also for the spam filtering. I think like any email provider currently, they use the classification algorithm to find whether the email is a spam or ham, whether the email is the unwanted email or the email that you are looking for. And at the same time, you can see now Google, they are using even to classify the new emails into three categories. And after that, also, first of all, they classify the emails into like either spam or ham. If the email is ham, is the email that you are looking for, so it will be into three categories: either the new email, the promotional, and then there is another option by Gmail currently to classify those new coming emails. From supervised machine learning to unsupervised machine learning. Unsupervised machine learning working on the data that are unlabeled. So the data are not predefined. We don't know what is the label of the data, and most of the current data that we have is considered as unlabeled data. So the algorithms and the unsupervised machine learning will automatically group and will automatically categorize the data based on the content and the features of the data. Okay, so that's why I called unsupervised machine learning. I'm self-sufficient in learning. Applications of the unsupervised machine learning is the clustering and association. Clustering, some of the current applications, we have the product customer segmentation. So we are segmenting, and this is especially by the e-commerce sites. So they group the customer based on the product they buy or based on like how much do they spend and so on. All right. Then moving from supervised machine learning and supervised machine learning to semi-supervised machine learning. Semi-supervised machine learning is considered as a combination between supervised machine learning and unsupervised machine learning. So most of the data that we have is considered as unlabeled data, except very few of them are labeled. So what do? We use unsupervised machine learning to cluster the data into groups. And then definitely in those groups, we are going to have very like few data are labeled. So that label can be used to be the label of the whole group. Why? Because those groups, they become together because they are sharing the same features. So it means if one of them are labeled, so that label can be used for all of them because they are sharing the same features. Okay. Then the last part of the last type of the machine learning is considered as the reinforcement learning. Reinforcement learning is quite different than those three types. Reinforcement learning, it is about building a model, and that model will have an action, will make an action, and will be evaluated for that action, either evaluated as the action that is a true action or the action was the wrong action. And one of the very common current application of this reinforcement learning is the self-driving car. And now the potential is there, and now there's a very wide and a huge demand on using reinforcement learning to improve the the autopilot cars, the autopilot train, the autopilot cab, and whatever. And it was said that by 2030, cars going to drive us. So most of the cars in the market going to be auto-driven. So we are not going to drive the cars. The cars going to drive us to work, to off, to shopping, to any other place. And there's also now a combination between reinforcement learning and deep learning to build a better model, to build a better accuracy model. Okay, so those are the types of the machine learning. Moving forward, the types of the deep learning. And we say deep learning is considered as a subfield of machine learning, and deep learning using artificial neural network to handle the huge amount of data. Before we starting with the types of the machine learning, the types of the deep learning, you may ask, so what is the difference between machine learning and deep learning? All right, the main differences or the significant difference between deep learning and machine learning. Deep learning, when you have more data, you will have better accuracy. While machine learning, there's a level, there's a limitation. When you are going to have more data, when the data continuously increase, then the performance of machine learning is not going to be as good as deep learning. Deep learning algorithms, the more data, the better accuracy you are going to get. So that's why we say deep learning algorithms are very promising. Promising in terms of what? In terms of the accuracy. Okay. And then one more thing about the deep learning. Deep learning doesn't need any feature engineering. We don't have to extract feature to be used to build any descriptive or predictive model. While in machine learning, we have to use the feature engineering. We have to extract features, and then based on those features, the machine learning algorithm is going to learn. Okay, so what are the types of the deep learning? First of all of those based on the artificial neural network or a neural network are the same, either ANN or NN. But the way of implementing the algorithm, the way of using the algorithm is different based on the application that we are looking for. So the first one, definitely I believe we have more types of the deep learning, but I'm sharing with you now the main types. And I just want to make this presentation today is like easy and informative for everyone, so everyone can understand what is going on, and to be like kind of motivation to start dig into this field. So the first one is artificial neural network, ANN, and the application is the text and image data. The second one, and it's the most common one, which is the convolution neural network, CNN, and this is for anything that related to image processing, image classification, object detection, facial recognition, and many other applications. CNN has very good result into these applications. Third one is RNN, the recursive neural network, and this is based on the text, a lot of applications based on the text by using the NLP. NLP is the natural language processing. Fourth one is the deep neural network. This is about the acoustic modeling, especially when it comes to sounds and voice. Then the fifth one is about the deep belief network, which is the working on the video and the motion detection. All right. So before we move to the applications of the artificial intelligence and how artificial intelligence and machine learning, big data, and all of those terms now involved in the current sectors, I just want to share with you that the demand on this field is going to continuously increase. It was said that by 2025 we are going to have 175 zeta byte of the data. Okay, the one zettabyte is considered as a 1 billion terabyte. So you can see like how huge is the amount of data, and you can see like how high is the demand to find people working on this data. And it was said also by 2026 will be 11 million 11.5 million job available for those people working in the field of big data, especially looking for data scientists. This is the worldwide. So the world is going to be in need for data scientists. And also that's why they say now data is the new oil, and they say AI is the new electricity. And I like this idiom: where there are data, then there is a solution. Okay. Before moving forward, I just want to share with you a very interesting thing, which are the income or the salaries of those people working as data scientists. And based on the worldwide, I would say it's like minimum or the average salary of data scientists, and those are junior data scientists, not the senior data scientists, could be started from the basic of 5,000K and above. If we talk about Malaysia, if we talk about Asia, I think in Malaysia, based on my research recently, could start from like 5 to 6,000 RM and above, and those are for juniors. Okay. If you ask me personally, I believe data scientists, those people with the skills, they should start providing their services. They should start providing their consultation instead of working in a company. But it's a good idea also to start working in a company to get the experience. Then after that, you move on. You are going to earn more, and the market is going to be more in need into these consultations and these services. All right. So, what are the applications of the big data? Definitely, applications of big data now involve in many sectors or every sector. But let me share with you some of those like in very high demand. One of them is the health care. When we talk about healthcare, definitely we're going to talk about the CRM. We are going to talk about the historical. We are going to get those data from the fitness tracker and so on, predicting the efficient budget for those, like especially those the insurance company, to have a better, more efficient plan with the same budget, to predict the right medicine, the right dose of of the medicine, and to predict the diseases, training, studying. But let me share with you a very interesting a project currently in high demand, which is working on the demography data. What does it mean working on the demography data? And what does it mean working on the demography data for the healthcare? Working on the demographic data. So we are going to work on the historical data, the patient data, and then we are going to link it to the demographical data. So, like for example, we are going to work on the state. We are going to collect the patient's data from that state, and based on the demographical data of that state, we are going to be able to predict what is the might like occur diseases, or what is the coming diseases. We can also predict like what are the right medicine to be used for that state. We can also predict, we can build a predictive model to improve the the efficiency of the healthcare and that state, and many other things. We can use AI and the big data into the healthcare. Moving forward, AI in education. Definitely, we have a huge amount of data now coming from the education, and when it comes to education, to use all the AI algorithms either for machine learning or deep learning, so we can do the task automation, and task automation could be even for marking the exams of the students. We can also personalize the learning process. So based on the sentiment analysis and based on the analysis of each student, we can build a model to find like each students, what do they need to learn, or what are the applications that they need to learn, or what are the things they need to improve, based on analyzing the process and analyzing their learning so far. And many other applications identify the classroom weakness. Also, we can help the students. That one is by the using the chatbot, and that one is like a 24/7 assistant. AI into the e-commerce. When it comes to e-commerce, then first of all, I would say the recommender system. And the recommender system is going to work on many things. The recommender system can be considered as customer service, can be considered as generating sales, can be considered as like uh, optimizing the price. Recommender system also can improve a lot of things, and those things are like for the benefit of both sides, customers and then the owners. Okay, AI for the government. When it comes to the government, I believe it's like, even I can see now, even in Malaysia, you can see like now government, they are allocating budget from the yearly budget, the annual budget, to work on the big data. And when you talk on the big data, then definitely they are going to use AI, they are going to use machine learning, they are going to use deep learning, they are going to use many other tools to work on the big data. So in general, what are the applications that government currently use? Is the one of them is the traffic optimization. So traffic optimization based on the building a predictive model, so they can predict when is the peak hour for the traffic. Then they can work on solving the issues of the traffic. They can work on like reduce the number of accidents and to make everyone safe. And definitely we can use those predictive models in cybersecurity and in crime, weather forecasting, drug evaluation, tax compliance, and many other applications. I would really emphasize, and I would really recommend. I would really like try to build awareness for, especially when it comes to government. I would really like to call government to start emphasizing more and start like working more on the data, because I believe like most of the infrastructure controlled by the government, right? And those infrastructure like they have a huge amount of data. So I believe government is the right, uh, is like a right part to make the difference and the right part to move and start working on the data, and can be the hub of the data. Those data also can be offered for individuals, can be offered for companies into AI to start also help and to start working on the data for better infrastructure, for better uh, service to provide the to the country. Okay, AI and for the entertainment and media, then definitely we talk about the some like ad targeting. You can see like when you use a social media now, there are a lot of ads, and not only the social media, even when you use the Google, you can see like a lot of Google ads, and this is all based on the AI. Many applications also for the content monetization, for the audience interest, and many others, and all good for the sake of like for us to provide better services, to get more services, and to find the things that we are looking for on social media or on the website much easier. And for the other party, where are those companies that they are providing those products or providing those services to sell more and to improve their sales. All right. And then definitely when it comes to application, there are very huge connection between the AI and the IoT, Internet of Things, because all of those devices are generating a lot of data. Then we can build all of those mentioned models on the data from the those devices. A one day applications of AI in our life, we use the navigator and all based on AI and data. We use the smart car, they are driving us all based on big data and AI. We text, and the text normally you can see that there's a lot of auto correction, and this is all based on the applications of AI. We use our devices to be unlocked based on our facial recognition. These are also based on AI. We use a lot of payment online, and those payment online, they use a lot of AI applications to predict the frauds, detect the fraud of the transactions and the true transactions. We use social media. Social media, they use a lot of AI applications. Then we use the smart houses or like any device that connected to our phone, and this is the IoT and the applications of AI. And what I said so far, it was on awareness, and this is all based on the what is currently now we are facing, which is the Industry Revolution 4.0. Industry Revolution 4.0 is all based on the digitization and automation. When it comes to automation, it means using the AI and using the big data. Moving forward, we are going to move to IR 4.0. IR 4.0 is going to be mainly based on big data and IoT. So you can see like how huge is the demand on the big data. And when it comes to big data, then definitely will be a huge demand, will be a huge involvement of the machine learning, of the AI, machine learning, and deep learning to work on that data. All right. Thank you so much. Thanks for having me. Please let me know if you have any question. And please reach me out by LinkedIn, by Facebook, by this email, or by my phone number. Thank you so much.
Thank you, Dr. Obay, for this sharing session around the definition of machine learning, data analytics, and data science. I believe that it's a very useful session for some of the beginners here. So we still have some time, maybe 2 minutes for the Q&A session. So maybe let me pick one or two questions from the question box there. All right. Let me see. Okay, we have one question over here. Let me read that out. So how should I start learning about big data? Should I learn about data analytics first, or any recommendations?
Okay, all right. Very good question. So when asking about the big data, so it means you are going to work on the data to analyze the data. Analyzing the data, it means you are going to get some insights from the data for the sake of building a model. Model could be predictive model or descriptive model. So it means you are going to use machine learning. So I would suggest first of all to start a practice Python programming language, the data type of a programming language, data structure of Python programming language, and then how to use all of those tools for data science by Python programming language. Then there are a lot of data sets available on the internet to be used for training purposes, to be used for applying all of the machine learning algorithms, deep learning algorithms, and all the available tools by Python for data science on that data. So it's going to be step by step, and then the first step is to build a model, upload it to GitHub, and then try to get comments from people or try to collaborate with people, try to get more data sets from the internet, work on this data set, improve more the skills of machine learning and deep learning algorithms, and improve also the result.
Okay, thank you for that, Dr. Obay. So I think we still can take one more question, but we need to wrap up in the next 1 minute, if that is okay. So let
Yeah.
me project that question. So which programming language would you recommend for a beginner?
All right. Very nice question. Definitely, I would recommend Python programming language. Why? Python programming language is considered as object-oriented multi-purpose programming language. It's considered as the easiest language to be learned, especially for those who are very fresh to computer programming language, and is considered as the computer language number one in terms of the tools, libraries, and functions when it comes to data science. And one more thing, very important, when it comes to Python programming language, you don't for data science, you don't have to learn everything about the programming language. You just have to learn the part that related to data science, how to use the data programming language for data science.
Okay, thank you so much, Dr. Obay, for that. Unfortunately, we will need to end this session soon because we need to get ready for the next session. So if you have any
All
more
right.
questions, feel free to just reach out to Dr. Obay. You can see the LinkedIn and the email and the contact number there. So with that, Dr. Obay, I'd like to thank you for joining this event. Really appreciate it
Thanks to you.
and hope to see you again next time.
Sure.
Thank you.
Thanks. Appreciate it. All right. Thank you. Bye
Thank
bye.
you. Bye-bye. So for
Bye.
the rest of the participants, let me share my screen. Give me one moment. We do have one more upcoming session by IR Dr. Lim Yu Shon, who is the Senior Vice President and Global Solution Development from Aerodyne Group. So he'll be talking about empowering social entrepreneurship through democratization of DT3. So if you're interested in that session, feel free to join in. Okay, thank you so much, and I'll see you again later.